here. So before we move on for the sixth session here, also this sixth session will be you can say lab kind of lab session here, where some hands-on related activities will be demonstrated by the speakers here. So before I invite our this session speaker, Dr. Anurag Singh, here further, let me tell you some brief bio about him. So Dr. Anurag Singh is assistant professor in Triple IT in Raipur in Electronics and Communication Engineering discipline. He has done his PhD in biomedical signal processing from IIT Guwahati, and he has completed his MTech from Triple IT Design and Manufacturing Jabalpur. And he was associated of a delegation for Indo-Japan Student Exchange Program, Genesis 2011. He has been a recipient of International Travel Grant Young Scientist by Department of Science and Technology, Government of India. He has been invited as an expert speaker here at national level workshop, medical image processing for biomedical application at additive manufacturing using Magic and Mimics 2018 at Triple IT DM Jabalpur. Moreover, he is further invited at national level workshop biomedical signal processing application at Guwahati University, Assam in 2016. His present research area includes biomedical signal image processing, wireless body data network, enabled remote healthcare applications using different physiological signals such as ECG, EEG, etc. Brain computer interface based application, multi-rate signal processing, compressed sensing, sparse representation related applications here. Before we move on further here, he has published more than 8 journal papers as well as 6 publication in international national conferences here. Along with that, he has written a book chapter here along with Dr. S. Dendapathy on a topic two-dimensional processing of multi-channel ECG signals for efficient exploration of inter and intra-channel correlations, advances communication and computing in the Springer publications here. So with this, now I request Dr. Anurag Singh to please take over this session. Sir, please.
I'm just going to share my slides. So I've shared my slides. Slides are visible to everyone?
Yes, yes, it is visible, sir, here. So go for the full screen mode and then start.
Okay. Okay, so let's start the session. My this talk is all about Internet of Things or IoT with Arduino. So far many sessions happened. I think most of you might have got a preliminary knowledge, preliminary information about IoT. Maybe Arduino so far not introduced so far. So I will try to interface these two things, IoT and Arduino. How this Arduino could be helpful in today's generation of IoT devices. Okay. So this will be the brief. This is the brief outline of my talk. Present. First, I will be discussing. I will introduce the IoT, Internet of Things. What this term means for us. Then I will very briefly introduce you the sensors. Then, taking these two as an introductory part, I will take you to introduce the Arduino. It is nothing but you can say that interfacing device for these two things. There we will see its hardware as well as programming aspect. Okay, then we will go into little more detail in this Arduino, which is nothing but a computing platform. So we will take some physical the Arduino physically. From here, I will try to demonstrate you a couple of examples. So first we will introduce. First, I will introduce the programming aspect of that thing, a little more detail, how to program it. And how to using this Arduino and many other sensor and IoT devices, how to do a little different things. So obviously, due to time limitation, I cannot have many more demonstration, but yes, I will try to cover a couple of demonstration to show you that how Arduino can be used in using for IoT based applications. Okay, so let me introduce the topic, this Arduino with this IoT. So first I will break into two parts. First, let's try to understand the IoT. What is IoT? Many of you might have heard this term earlier also. This IoT stands for Internet of Things. You know? So what is exactly mean? You know? So in the due to the a lot of advancement that is happening, currently, that happened in the past decade in communication technology, due to that advancement, that we are able to now give connection, or we are able to connect multiple devices through any many of the connection sources. Either it can be Wi-Fi, it can be Bluetooth, it can be any other connection medium, it can be Zigbee. Many communication technology we are having in the last one decade, I can say. Due to the advancement, many advancement happened, and that enable us to connect these devices at a lower cost, less power, with the less power, and obviously with the many smaller devices, size many smaller size devices, we can give connection. So all these devices, if connected devices, if we take together, they make a part of the so-called Internet of Things, that we call as a IoT devices. You know, second part of my topic was Arduino. That was the IoT part. Now Arduino. Why Arduino suddenly comes into picture? Uh, as I told, IoT is nothing but the network of different connected devices. So individually, these devices are having no meaning until unless you interface them, you connect them together for some meaningful task. So Arduino provides you the platform. Okay, so it's a flexible microcontroller and development kit. It is used to control devices and to read the data from the sensors, or other any devices which you are using. Okay, so when I'm introducing you to the IoT, Arduino is the best way to have that introduction. So we will try to understand this interfacing between Arduino and this IoT in the coming slides. Okay, so let's try to now understand this IoT and then Arduino a little more detail. As we go ahead, we will try to go into more and more deeper. So Internet of Things, first word is internet. So everyone is aware what is internet. It enables computers, connected through internet. Means like different computers can be anything. It can be your laptop, it can be your desktop, it can be your mobile phone, anything that is connected to internet. That is the ability that internet provides us. It enables us to display or manipulate the data which we are getting from these devices. That is the internet task. Now Internet of Things, there's a two terms gets combined. So how will that changes? So Internet of Think, before going into that, just imagine a scenario where you are having smaller devices, many smaller devices, that can sense. You are sitting in your room. Just imagine this is a scene where you are having multiple small devices which can sense temperature, smoke, humidity, light, condition, everything, just by sitting in your room. These are the devices which are there to sense these physical parameters, and they are taking those parameters and they are reporting them to web services. Understood? Something similar to this. This is one figure I have given. Just imagine some sort of this thing. To make it more clear, I can have uh, I can show you a little more a more clear picture. So here is the scenario I was saying you to imagine. You are sitting in your room. You are having different sensors, different smaller devices. Sensor I have not introduced, so I will not take the name sensor. Smaller devices which actually can interface that the outer world, the physical world. It can be either a smoke detector, It can be some let's suppose you are having plant in your home. You are having some soil sensor, moisture sensor, humidity sensor here. Uh, you can have some light sensor devices. You can have microwave there. You can have some sensor. So you can see all sensors are just independently working their environment, and they are receiving the data from there, and they are communicating to a some outer world that we are saying as a web services. So this is the word of IoT. This is the word of Internet of Things. Okay, so I can in a more simpler word, I can define, there's a computer, sensor, and actuators connected through internet protocol. So some connectivity. These are all devices which I just showed here. They are communicating to their physical environment, and they are communicating to the web services or internet. So what is the purpose of doing these things? From there you can have the the physical the data which those sensors are reading. For example, temperature sensor, let's suppose you have put in your room. So obviously it will be continuously measuring the temperature of your room and continuously reporting to the web services. From where you can see, so you can get the data, you can measure the data, you can manipulate the, if you want to further manipulation you can do with the data, that you can do easily. So that is the whole thing about IoT. Okay, so that is the uh, 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 picture of Internet of Things. A little more alternate definition I have given it. So it's a global network of smart devices. I can say smart because they can connect with each other, they can interface with each other, they can manipulate the data itself if you program them like that. Okay, so that is the important thing about these IoT devices. That's why they are called as smartly connected devices. They are the smart devices. For example, let's suppose your mobile phone, it's a smart device. No, similarly, many other IoT devices you can connect. You can make them interface. You can sense the data. You can take the decision. This means like those devices can take the decision based on the how you program them. Okay, so to understand this IoT concept more clearly in a more broader perspective, this is the best example, best figure I just found over internet, and I thought to show you people. So you can see here it's a very holistic picture of IoT has been shown. So you just see this whole picture. If that is just taken the example taken, how the rain droplets form and how they rejuvenate again, or they again reach to the sky. So how cloud forms, from the cloud how you get the rain, and once rain touches the soil, after that how it again reaches to the cloud. That is the whole process has been pictured here, have been demonstrated here in terms of IoT. Okay, so you can see the technology and innovation which are happening in the industry, or in the research field, wherever. Those technology and innovation, what they are giving the breakthrough in miniaturization, advancements in packaging, miniaturization in device size. They are giving you more and more advanced feature devices. Either it can be sensor or it can be any other devices. You can have new class of powerful but low cost and low power microcontrollers. So all these things you are getting from innovation and technology and innovation advantages. These are the actually byproduct of these so-called clouds. That is a technology innovation. So these are the droplets which you are getting as the output of this technology innovation. These droplets come to the soil. As you can see from this arrow, they come to the soil, and in the soil you are having this big tree. The roots of this big tree, these roots, what are these roots? So these droplet will help these roots to progress further. And what these roots, the analogy of these roots are nothing but they are can be they can help this technology can help you have better sensing devices, accelerometer, magnetometer, gyroscope. These are the sensors actually. Okay, so these droplets will help you nourish all these roots to have this better connecting devices. In terms of connectivity, you can have better GPS services, you can have better connectivity technology, NFC, you can have better Zigbee, all these things. So these are the roots of these bigger devices which get benefited from these droplets which are coming from here. Once these roots get stronger, in the analogy term I'm saying, so these are the technology. So through some software, if you can interface this technology, they can help you to gain a bigger and bigger tree that is being shown here. The tree is a resemblance of multiple application: smart smart parking, smart homes, smart grid, smart cars, much like any smart health, any application you take, if you have this technology interfaced with some software, that act as a root, that act as a stem of this tree, and using that you can have multiple other application. So this was the whole concept, and you just see this is not stopping here. This all advanced application will help you further. This arrow you can see, this they are helping to again build a better technology, better innovation, many things, and based on that you will get better droplets. It's like a good rain, and that rain will again, this cycle continues. Understood? So this is the whole picture of IoT, in terms of your physical world, in terms of technology, everything has been connected and shown that how each and every innovation and technology is connected with each other and helping each other to grow for better and better application, better technology. Okay, so I hope now that this concept of IoT is clear to everyone. Now, once we understood the IoT term, what are the for a device to be an IoT device, what are the requirement things to be there? First thing, it is the interact as a device is interacting with the physical world, so it must be having sensing ability for data collection. Okay, for onboard processing, if you want to process the data itself, it should have embedded processing capability to process the data. For communication capability, obviously it should have to interact with the outer world or to send the data to a remote location or to a web server. It should have software. Better software needs to be there. Supports it needs to be there, so that enable new class of services. Okay, better handling of that technology. It should have cloud-based support. It should have, for interacting with the cloud. And for last but not the least, it should have full security across the signal path. The security is a major concern nowadays in IoT technology. Okay, because many applications we are getting, but yes, we are not sure about the uh, the data which is flowing, is that secure or not. Okay, so security is another concern. So these are the features which just I discussed. They have been shown in the pictorial format. So you can see this is the word of IoT. So internet, this is the internet. These are the different things. In things, we are having different sensors, actuators, what I means like sensing devices which interact with the this internet. And how, before interacting with the internet, what they are doing, they are collecting the data from the environment. And what is there in the environment, and we the humans are in the environment, your home, your car, many things which are, there's a physical world, that is the environment. These things, so-called things in that term IoT, they interact with that, get the data, connect to the internet, and then interface through some interfacing devices. It's a computer, laptop, or whatever, and this is the user, this is you get the you access of those data. So many online supports are there for nowadays in IoT technology. There's a more and more advancement is happening. So online, there is a cloud-based support, things speak. There is a cloud-based support there for IoT technology, IoT-based devices. So you can go to this link to have more information about these things. Okay. Now you might be having a question that why there is a need of internet. We can have directly connected to here. Why this link from here to here it is going? Why can't we go directly here? Obviously we can go there directly, but it will not be a good thing. Why? Because that is the unique thing for an IoT device. Ability to communicate directly or indirectly with the internet. that makes our IoT devices unique in nature, because every time the data which an IoT device is sensing, you cannot every time physically access it. For example, let me give you an example. If you are just trying to monitor some person, the heart, you are monitoring the heart rate of any person that is located somewhere, let's say a remote location. Okay, so obviously the heart rate, the data you are continuously getting. So it's not physically every time possible that at each instant you are monitoring the data. At sometimes it may happen that you just because there's a human interruption involved there, so you may lose that data, and that is a critical case. If some medical emergency will be there, it will be not good thing. So that's why when a device can communicate directly to the web services or to some internet connectivity is there, it can direct at each instant it can store the data directly to there, and from there you can have some smart technology that can monitor the data. Means like if and but or if any emergency or means like some critical condition is reaching by analyzing the data or not. So that sort of smart means like technology you can enable so that those IoT devices can itself take the decision, based on without any human intervention. That is actually the application of telemedicine. Nowadays the telemedicine is something similar in that application. Okay, so for IoT device, what are the building blocks to make a IoT device? What are the we are now slowly switching towards the hardware. Trying to understand the hardware IoT. We just so far discussed about the basic definition and all, properties. Now we are just switching a little bit towards the hardware components. What are the hardware components of an IoT device? So these are the basic very fundamental building blocks of an IoT device: control units, sensors, communication modules, and power sources. They are the very basic units that is required for an IoT device. Out of that, is a control unit is the I can say that brain or is the heart of that IoT device. Because control unit, this microcontroller comes in this control unit, and microcontroller, as you might be knowing, it's a small computer in itself, having all the computational capability in a single integrated circuit. That microcontroller, you can imagine, it is having processor core, it is having memory, it is having programmable input output peripheral and everything. So in itself it is a complete computer, you can say, tiny computer, but having all the programmable, all the computer features. Okay, so in microcontroller you can say the brain that controls everything, read input from the sensors which are mounted on the IoT device, drives output after the getting the sensor data. It Any output device, if it is there, it drives the output device like LED, switch, motor, whatever is there at the output. It can drive those things. So microcontroller is a very important hardware or important part of your IoT device. Next thing is the microcontroller itself is sufficient? No. uh, because to interact with the physical world, you know that microcontroller cannot interact with the physical world. For example, let's suppose, very simple example if I can give, a temperature you want to measure of your room. So microcontroller itself cannot do that. It must have some data access. So obviously that data access you will have from the sensors. A temperature sensor you will be putting, that temperature sensor will be sensing the outer temperature of your room, let's suppose, and feeding it to the microcontroller that will process and then communicate it further. That is a separate thing. But the point to means like at which interaction is required from the physical world, a sensor is required. Okay, so that is a true for different application. Whenever you require to interact with the physical world, to control the any physical to detect some physical component, it can be temperature, it can be pressure, it can be humidity, it can be anything from the physical world. If you want to take the data, you must have to use sensors. And sensor uh, is nothing but it's a small device which interacts with the physical world and which captures the data, which senses the data from the outer world and feeds to the microcontroller for further processing. Okay, you can have a variety of sensors in this right now. Basically, you can classify them two parts: analog part and digital, analog sensors and digital sensor. Okay, so analog sensor which reads the analog data. Okay, for example, if you want to measure your heartbeat, so heart rate or any physiological signal which is generated from your body, that is actually a analog signal. So to read that analog signal, you must have to have an analog sensor. Okay, the digital sensor, you can have a digital sensor to read the digital data. Okay, digital analog you already know, so no need to discuss further. The technological advancement that is happening actually right now in sensor, this device, like in this device technology, that actually gave a very high boost to this IoT technology, IoT based applications, because right now, like here you can have, say, humidity and temperature sensor you are having. This is a very small tiny devices. It's a barometric pressure measuring device, it's a distance measuring device, it's a temperature sensor. So it's a small measuring device. Right now I can have, I have you can see that is a LDR. If you can see it, it's a small tiny sensor. So for example, this is one of the examples. Similarly, many different type of sensor right now in the market are, and it's quite cheaper. And due to that, that gave a boost actually to this IoT based applications. Okay, because very easily we can get any type of sensor which we want, and once we get the sensor, it means we are ready to get the data from the physical world. Once we get the data, we can have many computing platforms, like Arduino is one of the platform, to process the data and do any meaningful task, to any meaningful application. Okay, so right now I'm switching to Arduino. Okay, I suppose we have the data. Right now we use the sensor. It means we capture the data from the environment. Many sensor I can have at a time to collect the multiple data simultaneously. But how to process them data, how to communicate that data to for further processing, a computing platform is required. That's why this Arduino is suddenly coming into picture. Okay, because individually getting the data, sensing the data from the physical world is having no meaning, isn't it? You got the temperature from here, you got the pressure from here, you got the humidity from here, but how to interface them, or how to process them further for any meaningful application? You need some computational computing platform. So Arduino gives you the best computing platform to interface these devices. So because right now you can see that from IoT I just switches to sensor. So when I'm where I'm saying sensor, it means referring that IoT only, because sensor itself will be having not any meaning, until unless we have seen that what are the properties required for IoT. Okay, so computational purpose for interfacing different IoT devices are the data from the different sensors. You require some computing platform, and Arduino gives you the best computing platform. Okay, so what is Arduino? The question is, what is Arduino? Many of you might have already introduced knowledge about this Arduino. But I suppose that many of you might not be aware about the Arduino chip. So I will just briefly introduce this. What is Arduino? Okay, so Arduino is a open source physical computing platform. Okay, it's a computational, it gives you a computational platform. Okay, it's a open source. Why I'm saying open source? Because you can see that the open source meaning is that I can give you an example. For example, Linux software, Linux operating system. You might have heard the name Linux. Like Windows, that is a not a open source software that you need to pay money for purchasing any this Windows operating system. But Linux is a open source operating system. Now, open source means that is open for everyone. It's a freely available. Similarly, for Arduino, the software part, the software through which we communicate the Arduino. Obviously, hardware you need to purchase. But yes, the software is a open source. You can have your own software for controlling, for doing different tasks with the Arduino. That's why that is called open source. And when something is open source, you can always expect best out of that, because many people, that is available freely, so a lot of people are using. So you will find a wide community for that purpose, and you can get best out of that. So right now, that's why the people are preferring more and more to the open source softwares, which are open source, not licensed. Okay, so open source, that is not licensed, you can say. So simple microcontroller board and a development environment for writing softwares for the board. Okay, it is used to develop standalone interactive objects. Okay, standalone means as an individual identity, you can make anything. When I'm saying using simple Arduino, you can make your own Wi-Fi router, by just using the Arduino board and a couple of other simple devices. That is the meaning of a standalone. That is not depending on something else. It can be connected to a computer to retrieve or send data to the Arduino. Obviously, you can interface to the it to the computer, either to receive or just interact with your computer to receive the data, to manipulate the data, or whatever. You can assemble by just I'm having one Arduino chip with me, so you can see this is Arduino chip. It is visible to everyone. So this whole thing, you can I will introduce you different parts of it. So this board, this one complete board is called Arduino chip. Arduino Uno, that is called. So simply by taking these individual components, also you can assemble it. Or it comes from the Texas Instrument TI that makes this whole chip, that you can pre-assembled chip you can also purchase, and it's quite cheaper. It's hardly 200-300 rupees. Okay, so, and from the application perspective, it's too much. It's like a whole lot of application you can have for using this Arduino. Okay, so in the case of IoT based application, right now Arduino is the most usable chip. It's the most usable chip because of its different, a lot of advantages are there. I just listed a couple of things. As I told, it's inexpensive. As I told, it's a hardly 200-300 rupees, you can have a better chip. It's a cross platform. It's a not dependable to any particular platform. You can run it either Windows, Mac, Linux, whatever, because it was as an open source. So you can find out that software support for any operating system. It's easy to program. Both Arduino hardware software are open source, as extensible. As I told, these are open source. You can make your own Arduino program. You can make your own software for the Arduino. That is the meaning of open source. So that's this all benefit makes the Arduino most usable computing platform for most of the IoT or sensor-based devices application. Okay. So now let's go into little more detail about this Arduino. So Arduino boards comes in a different shape. As one of this, as I showed you, this is one. Is the first one, Arduino. This is called Arduino Uno. That is the chip name. So similarly, many other boards in other forms, Arduino comes. There's a Mega, LilyPad, Arduino BT, Arduino Nano, Arduino Mini. So these are the different actually Arduino boards. Depending on, and the classification is actually depends on multiple functionality. Okay, more and more functionality being added in different boards, so you can have a variety of boards. So going into little more detail about the understanding of this Arduino chip, Arduino board. This is the complete chip as I shown you. So if you see, it's the Arduino board clearly. You can have a major components which are there. That is you are having this USB port. You can see that if I show you physically also, this is the, you connect here, and the other part of this, that is the USB board that you just put it in your computer or any USB port to just manipulate or read the data which your this Arduino is getting. power input. This is the power input port. You can see there is a power from here. You can give the power to the device from a USB also. That is the power you can have. Okay, you have other multiple things for power supply. You are having multiple pins are there, 5 volt, 3.3 volt. There's a ground, so these are the pins to supply this dedicated power to this board. You are having analog pins from A0 to A5. 6 pins are there to read the analog data. As I told, this the example LDR I shown you. This is LDR sensor. You can see in my hand. So this reads the analog data. Okay, so if you want to read the analog data from this sensor, you need to put this sensor at this analog pins. Okay, because depending on the sensor type, as I told, I just explained, sensor can be a digital or analog sensor. So depending on which type of data it is sensing, you can put it at that respective pins. Okay, similarly there are digital pins here. These are the analog input, and here at the digital output you are having multiple pins from 0 to 13. So you can see that 14 pins are there for a digital output. Okay, and out of these 13 pins, you can see, can you notice this tilted sign at some pins? If you see clearly at 3, 5, 6, 9, 10, 11, these are the 3, 4, 5, 6 pins are there where you can have this type of sign, tilted sign before those pins. Okay, so there is a specific meaning of that tilted specific sign of this actually is showing that on these pins you can do pulse width modulation, PWM. Have you heard the PWM term, pulse width modulation? That is a specific modulation actually technique in communication. If you recall, then that actually used to modulate a wave according to the width of a pulse. So these pins actually supports this PWM. These 3, 5, 6, 8, 6 digital pins are there. So we will see the application. One of the demo I have put it to demonstrate the application of these pins. So these pins actually support PWM, and how that PWM operation we can use for application, that we will see in one of the demo. Okay, so right now you just know that all the digital pins are not similar. Few pins supports PWM, pulse width modulation also. Okay, this is the microcontroller. As I was saying, this is the brain of uh, this Arduino unit, which controls everything, Atmel microcontroller. Okay, so to see it a little more of zoomed version, you can have to see this is oscillator, and these are all things I already explained. So this is a more focused picture of this Arduino board. And this is another view. Here a little more details are there. So here these two pins were actually not showing. This is for a serial out transmission purpose. This is a reception purpose. These two pins, initial pins, transmission and reception. Okay, this is a reset button. This red button, you can see that is a reset button. If you press it, that the board will go into reset mode. Okay, so these are the major components I just showed you. Now we will try to in demo part, we will try to understand actually those things, that how to use that board in a different application. So now let's get into this Arduino, because the two interface and IoT device, we have to know the Arduino part more clearly. Okay, so let's start with the Arduino. No, so Arduino, as I told, the board part, the physical, the hardware, I just explained about different components. Now let's try to understand the software part, the software perspective. Hardware, we understood something about this Arduino. Now let's try to understand the software, so that we can interface this hardware through software. We can control the hardware through software. Okay, because that is the aim of the software. Software itself is meaningless. Through software you controls the hardware. Okay, so understanding of both things is required. So IDE, the integrated development environment, Okay, that allows you to program your board. That is the actually IDE. That is the programming module of your this chip. Okay, that allows you to program your board, make it do something. Program is you want to do something, you need to write a program. Okay, and when the way you wrote the program, your Arduino will work like that only. Will work according to that only. Okay, you edit a program on your computer, then upload it. So this is how actually the programming modules work. Once you wrote some program, okay, obviously writing you need to do in your computer. Okay, so how to interface? As you just simply connect this USB to your computer, you need a software. Actually there's a interfacing software which interfaces this Arduino to your computer. So once you install that thing, that is freely available. So once you install that thing, you can interface now this Arduino with your computer. Okay, now to write the program, you just write in that software in your computer. Okay, you edit it or whatever, it's like you want to modify it, you just upload or run it. It will get executed in the RAM. There's a RAM of this board. It will get executed there, and it will give you the corresponding output, whatever the program you wrote. Okay, so measuring and manipulating. Okay, so as I told, this Arduino, you can put the sensor in this Arduino chip. It will interface to the outer world. For example, let's suppose I'm having this LED, which I just put it in this way. You can see this LED example. I will just very shortly I will show you. So this is the one of the LED. You can see I have put it in this Arduino chip. Okay, so this LED, obviously this is a simple LED, so it cannot interface, it cannot capture, it does not have any sensing ability. So uh, if I just put a sensor at that thing, so it will have a interface to the real world. General purpose input and output pins, as I shown, they will take the input from the outer world, and this you can have the processing on the onboard processing on the Arduino, and you can have the some output pins as I shown you. So it is basically read sensor value from the input pin. That is the measuring you are doing. Manipulation means you process it according to your wish or according to your application, and then you write the value at the output pin. So I've shown you these are analog pins, and input, those are as the input pin, and you are having some output pins. So once you read the sensor data, you process it at the through the microcontroller of this Arduino on the chip, and then you just write it. Write means you just manipulated the things according to your purpose, and then you just write it at the output pins. So as obviously this is very clear that input and output can be analog and digital only. You know, just to get started with Arduino, there are, as I told, a lot of communities are there. To open community, as it is a open software, it provides open software. You can have a several help is available on the internet. For example, to get started, uh, from the Arduino official website, I have put these links. For Mac, if you are using Mac, then a guide for Arduino, get how to get started, you can get from this link. For Windows, for Linux, so there is a variety of support is available on the internet on through this it's official website only, or open communities are also there. Okay, so you can read this from these links. If you are just a beginner, if you have understood priorly used this Arduino, there's not a issue. Okay, for beginner, that is, these guides are available there on the internet. It will help out. Okay, now let's enter into the programming aspect, how to program it. Okay, the Arduino. So in the Arduino, the programming aspect of this Arduino, this whole programming is actually is based on C programming, C++. Okay, so it's actually in the initial developments. If you remember, many of you might have studied the microprocessor course. So this is the hardware actually. So in microprocessor, that supports actually the assembly language. But since assembly language was not that much supportable, it was not it was like that, not fast. you know But for practical purposes, if you are using something, you need a faster programming, faster execution. For that, later stage, it was modified, and in place of assembly languages, now this Arduino, it is happening since many years. Now it is supporting this programming in C or C++, because there's a good thing about this C or C++, it runs very fast. Okay, so it suits, it is suitable for practical applications. Okay, so if you remember, if you have studied the C or C++, then well and good. Then you can, you can have edge in Arduino interfacing. Okay, if you are beginner in C, C++, have not used earlier, that's not an issue. C, C++ is not that much difficult language. By just devoting a couple of days, you can have a hold over it. Okay, so to get started with the Arduino programming, this is the basic two modules are of programming: wired setup and wired loop. Okay, wired, if you remember, if your program does not return some output, you put wired. Wired main, if you remember from your uh, UG classes, if you have studied the C, C++. So in Arduino programming, there are these two separate modules are there. This is wired setup, this is wired loop. So once you program your Arduino, let's suppose you want to simple application. There's a my first demo. Just you want to switch on and off the LED. Okay, so switching on and switching off the LED, you need to have a first the assembly setup. Setup means which pin you need to use, what are the parameters you want to initialize, all those things. So those things you just write here in this wired setup. Do be careful about with this brackets, because that otherwise you will get an error out of that. So this wired setup, whatever you wrote here, that will run once, because that is just initialization. You initialize the pins, which pin you are using of the Arduino, which pin you are using as the output, all those things initialization you do here. And then comes out to be this second loop, second module of the program. This is a standard approach, or this is the standard structure of the Arduino programming. You always have these two things: wired setup and wired loop. Okay, so in wired loop, what you get actually in wired loop, you need to write your main code. Main code means the logic of your main code. For example, let's suppose I give the example of heartbeat. You take you use a pulse sensor. Okay, you try to calculate the heartbeat, your heartbeat. Okay, so taking the pulse sensor, taking the data, how you are calculating the heart rate. So that is actually main program you need to write. That is the logic, some logic you need to use from the heart rate, means like how from the pulse you calculate the heart rate. So that needs to be written here in this part. Understood? So you are having these two particular modules, setup and loop. So as I told, so this thing actually will run once, and wired loop, as its name suggests, it will run multiple times until unless you just uh, terminate it. That's why it is a loop. So it will run once, it will keep on running as I show you in the example. So once you switch on the LED, it will uh, remain switched on until unless you reset it. Understood? So that's why this is the main program. Until unless you manually stops it, it will not stop. Okay, but in the setup, it will run once only. Now let's try to understand a couple of more basic things about Arduino, the programming aspect. A pin on the Arduino can be set as input or output by using pin mode command. So this pin mode command, that is the one command in the Arduino that actually used to set the pin, which pin number. As I told, there are multiple pin numbers. For example, for analog input, if you see, there are 6 pins are there, A0 to A5. For digital output, you are having 13 pins. So which pin you are actually using for input or output, you need to mention that. Okay, so pin mode is the command for using that. So pin mode 13 output, it means what? I am dedicating the 13 command, okay, sorry, 13 pin as the output pin. Set pin 13 as the output pin. If I write it like this, it means this thing, okay. If I put this output replaced by input, it means the set pin 13 as the input pin. So I need to put my take the input data at this 13 pin, okay, and that your Arduino will take as an input, okay. So that was the reading means like selecting a pin using pin mode command, okay. Now reading and writing, okay, how you read then write the data, okay. For that, digital write is the command. Digital write, or if the data is digital, if you are putting in place of digital, if you are putting analog, it means the data is analog part, so you write the analog data in that way, okay. So digital write 13 low, what does that mean? It means makes the output voltage on pin 13 0. So low volt and high, as you know in digital, low means 0 and high means it's a 5 volt, or higher volt means like it's a low and high, two logics are there. So you can corresponding voltage, you can assign any voltage. Standard form, it is 0 and 5 volt, okay. So if you are writing digital write it this way, it means 13 pin you are making 13 pin low, okay. So anything which will be connected to the 13 pin will go low using this command digital write, so that if you are putting high at this thing, it means it will send 5 volt at the 13 pin. So whatever the device is connected at the 13 pin, it will make it will supply start supply the, you know. So you will have that will means like if it is LED, it will switch on in this case. If it is means like LED connected to 13, so in this case it will switch off because voltage is now 0 volt. Understood? Int button state, digital read the value up into in button state, okay. So button state simply, that is a variable. If you remember C, but the basic understanding about C, if you know, these are the simple things to understand, not harder things. Some of these specific commands are there for they are very close to this Arduino, that is not in C you may have, but that are very little, you know. So even if you are having little exposure about the C++ language, you can have a better control over the Arduino programming, okay. So here that is showing int means that is the data type. The button state is the data type, integer type data, okay. That will digital read value of pin 2, okay. That will read from the pin 2 digital data, it will read, you know, and it will store in the this int this button state is a variable where it will store it. Understood? So that was the my the basic understanding I just gave you about the uh, this software part, okay. Now obviously it will not be clear until unless we see it, okay. So let's try to a couple of examples. As I told, it's a time is quite limited, so we cannot have multiple demonstration, but yes, I can show you couple of demonstration how to program a uh, uh, Arduino for any application. For example, here I just take very simple example, very simple, as it's a very elementary example. You can see, you know, those who have used Arduino, for them that's a child's play, okay. But those who are new, that may be interesting how to control the blinking of an LED, okay, through Arduino. LED I can have connection in this uh, Arduino, and how it will I can control the blinking, okay. So before doing that demonstration, a little bit understanding about an LED may help you. So LED and many of you people might be aware there is a light emitting diode. It's a you can have you are having two legs. One is a positive and one is a negative. So polarity is there. So this slide meaning of is like the purpose of this slide to make you aware about the polarity, because while connection you have to be sure about the cathode and anode and the positive pin and negative pin. So by convention, there's a longer pin is a positive, the smaller pin is a negative pin. Okay. So for example, if I show you, I'm having a LED, you can see. So you are having a smaller pin and black pin, a larger pin. So while connecting it to the Arduino or to the breadboard, you need to have the polarity in your mind. Okay, so the connection you can have for this, that's a very basic elementary program. So you can use a breadboard, either use a breadboard, for this connection, or you can use the inbuilt uh, circuit of this Arduino also for this purpose. Because in Arduino we are having a inbuilt LED. As I will show you the program, there is an inbuilt LED at this place, so you can control that LED also through program. Okay. So this is a breadboard. I think many of you have already used. On the for a larger complex circuit, you can use the breadboard. So the different parallel and series connections are there. So for a complex circuitry, it's advisable to use a breadboard. So for example, here you can see that how you can wiring of LED you can do for this purpose, like blink control. If I want to control the blink of an LED, how I can wire it. Okay, so as I told, two things: you can use an external LED, in a breadboard like this, or you can use the inbuilt LED also. So you can see the to connect it, I have used this pins. If you remember, this analog pin, this is a digital pin. So I just connected uh, this obviously through an register. If you remember, this is a register. Okay, so just the register has been put actually just for a safer purpose, as you can read here. If you just don't remember the polarity and you just put a wrong connection, so in that case, to avoid the damage, there's a resistance has been used. A register is used, so actually that will act as a that will as a safer side. You just put a register along with this LED. So this is the connection. So you can see the negative is connected to the ground, and this positive is connected to this particular pin. And once you give the power through this USB, and you program it in such a way that output of this Arduino, the output of this LED is like you make this output pin 13 number pin high. Okay, so you can see that at 13 number pin, this positive of this is is connected. So if you just send a high signal at this 13 number pin, it will simply it will simply control this LED blinking. So how to write a simple program, very basic program in terms of this Arduino language, that is basically a C++ only. So as I told in the initial, uh, you are having a two this setup. The programming setup is having two modules: wired setup and wired loop. So in wired setup, as I told, you first need to initialize. As I told, in the 13 number pin, you are adding the output. You can see this is connected to the 13 number pin. This is 13 number pin. So you LED pin you just set to the 13 1 3. Okay, pin mode command, as I just told, to select the particular pin, you need to use this particular command, pin mode. Okay, so you just use pin command, pin mode, LED pin output. So what you are doing actually, LED pin value of LED pin is 13, so you are actually doing pin mode 13 output. So you are sending the output to the 13 number pin. That is the meaning of this thing. Okay, so this is the wired setup, means like it will run once. Okay, now the main command, means like the main program uh, uh, which you need to write in the while loop command. So while loop, you started bracket. Now what is the as I told, the logic of making this LED blink, or just means like making this LED on and off. You send a high signal and you send a low signal. That is how you can control. Simply think the logic. If you high signal means giving the 5 volt to the LED, and then I'm making it 0. If I use that logic, it will simply make it blink, isn't it? That's a simple logic. So in terms of Arduino language, how I will write it, I will simply digital write Okay, LED pin 13 I have used. I am sending this 13 number pin high. When I'm saying high, it means 5 volt will be sent to the 13 number pin. So if you see this thing, 13 number pin is connected to the positive. So at the positive leg of this LED will be connected to the 5 volt, okay, and negative is to the ground. So obviously it will make it the LED on. Okay, I will since I need to blink it, just put a delay of some duration. Let's suppose a delay 500. So it's a 500 millisecond delay. It will keep this pin high, and then you write low, digital write LED pin low. So you send low signal or 0 volt to this LED pin, that is 13 number, and you just 0 volt will be sent to 13 pin. It will become a 0 volt. So your pin will this LED will get switched off. You can have a delay, and again 500. So after every 500 millisecond, your this LED will blink, or it will switch on. Means like the blinking will be happening at this 500 millisecond duration. Okay, so the explanation is written here. For more detail, you can read that explanation. Okay, so let's try to see that thing, this whole thing in the Arduino program itself. Okay, so let me open this Arduino software that I have installed here. So you see this Arduino, a small this window, everyone. This small window is shown. I have just opened this small window, that is nothing but this Arduino software. Can you see it?
Yes, sir, clearly.
It's visible, everyone?
Yes, yes, sir.
Okay, fine. So just this is the interface. Actually, if I just cut it, it will just close. So this software I've installed from the link which I just shown you. So if I just open it, it will open that interface. This is the Arduino interface. This means like I can say in terms of language, if I say that is the editor window, I can say. In MATLAB, you might have done programming in MATLAB. So this is the editor window. Okay. So as I shown, this is the standard programming module. Here, there's a wide setup. There's a wide loop. Okay. So you can write either the setup part, whatever you are doing in the first module, and in the second module you can write your main program. So for just blinking this LED, let's try to just try to write that thing. Before writing that thing, I will make you understand. This interface, I will make you to understand something. You can see there are multiple buttons there. So these multiple buttons are there. It's just whatever you write, it will verify for errors. It will upload it to the RAM of your this is like your Arduino. It means like uploading means it will burn, sort of. It will burn the code whatever you have written here. It means like burning in the sense it will go into implementation. Okay, this thing is for a new window, to open a new window. This arrow is showing for opening anything. Here you can important things are there. You can see here actually you can open your new file, a new program which you have saved from here. Or second thing, you can use the inbuilt programs. There are a lot of programs as an example are given. Can you see it? For there are different actually different area, and in every area there are multiple sample programs are given. Yes or no? Can you see it?
Yes, sir. We can see it.
Yes. So you just open it. Let's suppose analog in, or that is the example given. Example you can find out at this link also. There is a link given. So these are the sample programs given from the this developer of this kit. Okay, so a lot of sample programs are given. So those who are new, those who have done something, that is not a issue. I'm just targeting those who are almost new. There's a beginners. So this sample program will help you a lot. to understand the programming and to control the Arduino hardware. Okay, so you can see this is the sample program given for this particular purpose: analog input, analog output, serial. Okay, from there you can simply upload, verify, you can upload, you can run it and just experiment it, how to do that thing. So many programs are given, you can see, for different uh, areas: digital without delay button program, state change detection, tone melody, obviously to run it will run, but you need to arrange the hardware. Yeah, for example, this a tone module, this for example, let's suppose tone keyboard. This is the example I just opened. So you need only this Arduino is not sufficient, you need a couple of more equipments. So you can see the detail is given: 3 4 sensing register you required. Okay, 3 10 kilo ohm register you required, 8 ohm speaker you require. So these things you require to use this program. Okay, because until unless you did not set up those things, you cannot this running this program will not help you. Okay, so the detail is given here in each and every setup program. You can read that thing, you just read those equipments required, you just set up as per given. More detail you can find, there's a link also given from the official website of Arduino. Here you can see there is an official website of Arduino. There you will get more detail of these sample programs. That is the best thing to learn for a beginner. Okay, for example, let's suppose I will just from there only I will just show you this particular command. It's like, but this particular task, there's a blinking. Okay, let's suppose I just opened this blink things. So I'm also using this one inbuilt command only, but in inbuilt sample program you cannot edit. Okay, so if you want to edit in anything in the inbuilt command, obviously you have to save it at other place in your computer. Okay, so by this in this blinking program, I'm trying to control the blinking of the inbuilt LED. Okay, the inbuilt LED, I'm just going to control it. Okay, so this is the simple program. As you can see in my slides, the same program is there here. Only thing is that since I'm using a, okay, first let me run it and then I will explain it. Okay, so now just I connected this Arduino to my computer. Okay, now I will, from here I can verify it. Okay, I will switch, click here. You can see that compiling a sketch. Done compiling. It means compilation is done. Second, upload. Now whatever the code is there, it is uploaded at the means like microcontroller of this kit. Now can you see the blinking of this LED? Everyone, this is the controlling of the LED. Onboard LED. I'm not using any external LED. This is the onboard LED which is already there in the board that I'm trying to control. Can you see it, everyone? That LED is blinking. Yes.
Yes, sir.
So this is just simple. This is a very basic and simple program to control this LED. Here you can control the LED this delay time. As it this is just I this program in other place, so I can control this blinking. Let's suppose I want to make the LED switched on for a longer duration. I just increase this delay time. Let's suppose 500. I just made it 500. From 50 to I made it 500. So you will see, notice the change. Now right now it is blinking completely. It's equal 50-50. 50% time it is on and 50% time it is off. Now after making 500, that high time is 500. I want to make this LED switched on 500 millisecond and off for 50 second. So I just change this this part. Now again I will verify it. Okay, done compilation. Now I will upload it. Then you keep a note of this LED. Okay, whether it is changing or not. Can you notice the change? Now it is blinking for a that rate of blinking decreased. Now it is on for a longer duration. Yes.
Yes, sir. Yes, sir.
Just it's a you can see that is just a 2-line program, 2 3 line program. You can use your external LED also. What you need to, here you can see there is the program which I showed you, that you need to put your external LED at the pin number 13. So in this program, you just LED button, you need to verify, just mention at this top LED button is equal to 13, and you just run the code. It will uh, uh, run that external LED also. So since my time is not that much, so I'm just I need to accelerate a little bit things, otherwise I cannot cover the whole thing. Okay, that was the one basic demonstration I gave, blinking of LED. Now let's try to see other application. That's a simple command. So what are the other things you can do? That is the simple, by changing the time duration delay, I just control the blinking of LED, making it high for some duration, making it low for another duration. These are the simple challenges you can do. you know you can see my slides, a few challenges I put. So blink with the 200 millisecond interval, that I showed you from where you can control that. Blink the mimic to heartbeat. So you just need to control the blinking in such a way that it mimics a heartbeat. So you need to make the rate of that illumination more faster. So there's a simple things you can do with this command. Let's see the second demonstration. Can I make the LED fade? That was the only on and off, some duration. Now fading, can I use fading operation? Can I use this LED? You might have seen in the marriages, a lot of LEDs bulbs are there, they starts fading and then defades, that fading and defading operation that happens. So can you just mimic, or can you produce similar effect using this LED with your Arduino board? Yes, you can do it. How? Let's and now again, the using for doing this thing, as I told, if you remember, as I told, there are pulse width modulation pins. Some pins are the digital output. As you can see, there are the tilted tilted signs. You can see the digital pins, there are some tilted signs. Using those tilted digital pins, you can mimic, or you can implement this pulse width modulation, and that modulation you can use for fading operation to control this fading. Okay, so fading actually, it's something, if you just take the resemblance, fading is something, means you are trying to actually producing an analog output. Digital output is what, either making it on or off by sending low or high. But here fading means that is slowly getting low, sharper, and then slowly becoming deeper. So it's a sort of mimicking the analog signal. So that's why in this particular case I will use the digital pins, and along with these digital pins I will try to, the writing part. Earlier I was using the digital write, here I will use the analog write, because I am trying to mimic analog things, analog signal. Okay, so how I will just simple logic I can use to make it happen using this hardware programming. I will just quickly explain you this program, and then we will show the demonstration. Okay, so here you can see this programming slide. There's a simple program I have given. So you, if you see it clearly, using this previous hardware based, there's a discussion, means like software based discussion, means like the programming, whatever I just explained you, they're just using that thing I'm trying to explain you. What happened? Network issue is there. Okay, anyway, okay. So just see, this is a simple logic. Simple logic is what you want to make the LED fade. Fade means decreasing the intensity, and you want to, after fading, you want to make it brighter. That is what the means fading. Now if it is a higher intensity, you want to reduce it slowly, and then you want to grow it slowly. That is what the fading means. So the logic, if you think, because everything you have to program, so before programming you need to think about the logic, what logic I can put. So it's just a brightness, the controlling means like if you control its brightness in some way, you can increase its brightness or decrease its brightness in some way. So what the simple logic I used, I declared a brightness variable. Brightness there I put 0. So you can see that if you remember, there's a color LED means like intensity wise. If you see, for a 8-bit something, there can be 0 to 255 levels, different intensity values. So I just put the initial. I just take the pin, LED pin. I have selected the LED pin at which my output will go. So 9th number pin I have put as a LED, means like digital output. So 9 number pin, you can say that is a digital pin having PWM support. Pulse width modulation support is there at this 9th number pin. If you see it clearly, okay. So I just set the pin number 9 as a output pin. Brightness level I put 0. This is the random value. I just assign any random value 25. How many points of the fade means like what is it actually controls the fading. How fastly you are fading you want to do, or how slowly you want to do, that you can control by this variable. It's a simple variable. You can change your variable and just see what is the result. Okay. So in the wired setup, I just declare this the pin mode LED number means like 9 number LED as an output pin that I just declared here. Then in my coming to my main loop, so I just use analog write. As I told, here we are trying to mimic the analog signal. So I just use this analog write bright LED is 9 number LED and brightness. So brightness value is 0. So 0 number brightness number value I'm sending to the pin number 9. So initially brightness will be 0. Analog write will be 0 at the 9 number pin. Okay. Now how to change the brightness? I use the simple programming. Bright equal to brightness plus fade amount. So initial brightness amount will be 0. Fade amount is 25. So you can see the overall brightness, it will increase from 0 to 225. Okay, isn't it? So that is how the brightness will change, and that is coming in a loop. So one time it will happen, and then it loop ends, it will revert, it will again restart. Now what will happen if the fading is like after increasing this, it reaches to a maximum at the intensity is a 255, or if it is below 0. So in that case, actually I'm just trying to revert the fading amount, whatever I just declared. I'm putting this a minus 25. So it's a simple actually logic I have put. You can put a delay of 30 seconds also. So this is I'm just not going into much detail about the programming, because programming is something very subjective. You can have your own logic also. You just don't follow my logic. You can have your own logic also. So any logic you can put for these things. So let me show this how I can do it. So I just made this program in my Blink 2. That is the, sorry, no, it is not that program. It's the fading. That the program actually I saved it, so that's why it is showing there. So this is the same program which I showed you. I'm just running it in the Arduino LED pin 9. So before that I need to put it in the LED pin. So you can see this is Arduino. This is I am having switch. So LED 9 number pin, we need to take the output. So positive pin, this is a longer range, I have to put in the 9 number. So I'm just putting it in the 9th number pin. So 8, 9, and the smaller pin I need to put in the ground. Okay. So you can see I just put the in a 9 number, the longer leg, and the smaller leg I put in the in the ground position. 1, 2, 3, 4. Okay. Now I will connect this to the my computer. I will now run this program. Let me see whether it's running or not. So it is compiling a sketch. Done compiling, it means it's okay. Compilation is fine. Let's see the output, whether it gives the output or not. Yes, I think connection was not proper. Can you see the external LED I have just put on these things? The blinking, can you see? Visible to everyone? Yes.
Yes, sir.
Everyone say so. That's a simple, you can see that is a simple program. You can just change it, the fading amount. Let's suppose a 125, from fading amount 125, I just reduce it from to 25. Okay, I change it to 25. Now again I will verify and I will run it. Let's see what the exact, can you see the change by
Sir,
changing the,
just
what is
move the,
happening?
move that to the some dark place, sir.
Yeah,
Background
actually
is white. That is a, we can't see it.
Yes, reducing the fading amount, actually reducing the rate of blinking. Okay, if I increase
Acha.
it, let's suppose I made it 200. Okay, so it will blink very fast because that fading amount will be changing very fastly. Can you see? Yes. So this is how you can see, using the simple program, you can control. This is the simplest example. This is the basic, very elementary example I just showed you, because just I assume that I don't know about the background of many of you people, that whether have you used this kit or not. But that's why I just choose very simple examples, to make you first understand it, that how to control the things. Okay, so these were the two example, two demonstration about this LED controlling I just showed you. There are many more examples, many more, so due to time limitation I cannot obviously go through every demonstration. But yes, I can just quick, I can show you that what can be different application. Okay, because my time is almost getting over. So these are the challenges you can do in the fading challenge. You can use two LED, make their combination. One will be fade, other will be defade. Like this, any combination of these multiple LEDs you can have. So these are the fading challenge you can do. Third is the heart rate computation. This is the third demo. This is a bit complex demo. So let me show you that demo. Then I will finish it. This is a heart rate computation. Calculating your heart rate using the simple analog sensor, simple analog sensor. So you can see I have used a this Arduino board. This is a simple sensor. This is the pulse sensor, simple sensor I'm using. Can you see it, everyone? this is
Yes, sir.
this is a simple pulse sensor, which can sense your pulse. This is the USB port of that thing. Using this simple thing and one LED, just to show you that whether it is means like whether it will be capturing your pulse or not, using this pulse sensor. So I will just simply demonstrate this thing, because time is very limited. So it will be not that much time to demonstrate you every like line of code, but let me how much I can show you. So this program, before explaining that, let me tell that this is not a very accurate program for a heart rate calculation. Obviously roughly it will give you some correct, but since I'm using a very raw form of the sensor, you can see this sensor is very sorry, I'm not. Yes, this is a pulse sensor. So it's sensor, it's not covered. It's a very in raw form. So actually, it's a photodiode based sensor. Okay, so when you put their finger here, it senses your pulses, and try to capture the compute the heart rate out of that. But here, since this is open, so actually it is getting interference from the outer world also. That's why I told that this will not give you very accurate, but yes, it will give you some reading, some close reading of your heart rate. Let's try to run the program and just try to see it. So this is the program I just made for heart rate calculation. As I told, you have to make up some logic, to compute something. So here I just use one logic to compute the heart rate. Once you are having a pulse means the heart rate. If everyone, any one of you have seen your heart rate, how it actually shows. So it is just a periodic pulse, So at a higher peak of that pulse, that is called the R wave. So heart rate is nothing but the number of beats your heart is beating per minute. Per minute, how many times your heart is beating. So simple logic of calculating heart rate from the pulse, to find out the, okay, first, to find out those peaks, actually, the bigger peaks in your heart signal, and then then detecting the other peak, and then calculating the, the time. It's like obviously one bit, what is the duration. Similarly, multiple bits you can calculate and just see that how many beats are actually producing your heart in 1 minute. That is the simple logic you can use. So obviously, due to time limitation, this is a bit bigger program, so I cannot explain you every detail, but this is the logic I have used. Detected first peak, that how that will detect that your this pulse sensor will detect it. Okay, this will, once I will put it here, it will sense your pulse. It will send interrupt at the point it will get the first peak. When the second peak will come, it will again detect, send the interrupt to the microcontroller, to the your Arduino board. Then it will, the duration it calculates. Similarly, multiple duration it will calculate and take the average to find out your number of beats your heart is beating per second, per minute. Okay, so this is the logic I have used. So bits, this pin, you can see the pin location I have shown here. It's very difficult to demonstrate in an online board, but still I'm trying my best. You can see here, I have put these things in an analog pin. Analog, can you see? This sensor, as I told, it calculates the analog input. It takes the analog input because your heart, your pulse is an analog signal. So I'm taking this analog pins as an input. Can you see it, everyone?
Yes, sir.
These pins I have put at the analog pins. This LED, I just put at the digital pin just to show you. This LED will blink at each time when this sensor will detect one pulse. So that is just the role of LED. Just make you aware that yes, it is sensing that, sensing the data. Okay, let's try to run it and just try to see it, whether we are getting it or not. So I just compilation I completed. This is uploading is done. Now the output, you can see there's the output is a data. Still I have not put my fingers. Now I will put my fingers here and try to see where is the data going. So for calculating the data, actually you need to see the serial port. That also is important thing. Actually, you need to see the port of this Arduino. So from here you can have that port. This is the serial port. Can you see the output? Can you see the output?
Yes, sir.
The data
Calculate.
it is receiving, as I told, it's a not exactly, it's
Yes.
a not exactly it's like accurate. So sometimes due to the interference, sometimes it is going very high also. This is the how you can get the data from that sensor. It is not,
Okay.
because for that we need to cover this pulse, impulse, this sensor, you need to cover it so that it does not get interference from the outer side. So it's not accurate, but this is how you can receive the data from that pulse. That pulse is, your sensor is getting the data from Arduino. It is getting processed and coming in your computer. So from here you can save the data, you can process it further for any purpose. Understood? Clear है?
Yes, sir.
कौन से port पर जाएगा, that is also important thing. So
Yes.
which port it will go. So to see the port,
Serial.
actually here in the tool part you can see the serial monitor. From there I was seeing the data. So here is that port from at which you will see the data which is coming from your sensor. Okay, so that was all from my side, the demonstration purpose. Sorry, I had many other things to cover, but due to time limitation I could not cover it. Similarly, you can have multiple other application like switch. You can connect a simple switch with your Arduino. You have given the program, you can run it. If you are having, you can run it and just see it. You can simple connect LDR with your Arduino light dependent register for any application. Okay, similarly many more applications are there. It's very difficult to cover, but I've shown you the picture so that you should be knowing that what can you do with Arduino. This is a humidity and temperature monitoring device, made from the Arduino. Simply you can use a battery and some other small components. You can make a temperature and monitoring sensor. You can drive a motor, simple a servo motor you can drive by just putting in using this Arduino board along with the transistor. Okay, so here I'm not explaining many detail, but yes, I'm giving you just little a glimpse. This is how you can make your own Wi-Fi. If you want to make your own Wi-Fi using this Arduino board, you can have a small chip. This Wi-Fi chip comes in the market hardly maybe within 500 or something. You can get this small chip Wi-Fi. You can connect this Wi-Fi chip along with this Arduino to make your own Wi-Fi router. Understood? So obviously that programming part you need to see. So I have given this link. You can see here the link is given for online support. A lot of online support is available for all of these application. You can explore for further applications. Okay, so these are the more details of those things. So the time is not there, so I'm not going into those things. Just I'm finishing it here. Okay, so thank you very much for being so patient. If you're having any question, you can quickly ask, because I'm already running out of time. Any questions? So anyone? Yes, now session is open for question. If you're having any question, you can ask. Anyone? Yes, any question or should I? Okay. Okay, fine. No question from your side. So I'm just ending the session. Okay, thank you for your participation. Thank you very much.
Okay, so thank you to Dr. Anurag Singh for the nice session and for conducting this nice talk. So I hope that all the participants have some knowledge about the basics of the Arduino and all these things. So, so now as a token of thanks, I would like to request Dr. Shesha Yadavni Ghosh, Assistant Professor of Triple IT in Nea Raipur, to hand over a little memento to our Dr. Anurag Singh sir. So please have a big clap for him. Thank you. Thank you, madam, for handovering the memento to Dr. Anurag sir.
Thank you, sir. Thank you very much.
So, thanks to all the participants, and thanks to the speaker for the wonderful session. So your feedback link will be shared by the coordinator maybe after some time, because he is now somewhat busy. So after maybe some time, he will be sharing the feedback link, and your attendances will be automatically be recorded in the WebEx session. And after the WebEx session, we can actually collect your attendance record. Thanks to all of you. Thank you. Have a good day.